Hi, so today we're going to talk about multiplying polynomials. So we're going to be multiplying polynomials. Okay, so we're going to look at some basic examples and a little bit harder as well. So what we have here is we actually have a monomial because it's got 4 times x and there's no addition or subtraction with it. And then we have a trinomial, meaning it's got 3 terms. So 4x is 1 term and 3x squared plus 5x plus 9 is 3 terms. So when we want to multiply them, remember the parentheses are telling us to multiply, we're really just using the distributive property. So we're going to distribute and multiply the 4x to that, and that part. So you got to be really careful because you can make mistakes as you're doing that. I like the arrows to help me. So I have to do 4 times 3, which is 12x cubed, because I have to do x times x squared, which gives me x cubed. Then I do 4x times 5x, which is going to give me 20x squared. And then 4x times 9 is going to give me 36. So 12x cubed plus 20x squared plus 36 would be if I multiplied the polynomials. If I worked backwards to get this, that would be factoring the polynomial, pulling out the greatest common factor in this case. All right. Then they get a little bit more involved. And I think in Algebra 1, you probably learned that when you have 2 binomials, these are 2 binomials because they have 2 terms, that you could multiply them. Now, I know a lot of teachers teach FOIL, so I'm going to show you that method. FOIL stands for multiply the first terms, multiply the outer terms, multiply the inner terms, and multiply the last terms. The reason I'm not really fond of FOIL, but if you use it, that's fine, is just because it only works in this one case. It only works with 2 binomials. And it doesn't really tell you what you're doing. But if we're going to FOIL, then I'm really big on using the arrows. So I'm going to first multiply the first. What it actually is, FOIL actually is the distributive property twice. Okay, so I'm going to do 3x times 8x, which is going to give me 24x squared. I'm going to do 3x times 2. Those are the outers. So plus 6x. I'm going to do negative 1 times 8x, which is negative 8x. And I'm going to do negative 1 times 2, which is going to give me negative 2. Now I have to combine the like terms, which are the ones, same variable raised to the same exponent. That's going to give me 24x squared minus 2x minus 2. And so I've multiplied the polynomials. There is another way, though. You can use an area model because you know that area, if you find the area of a rectangle, you do the length times the width. So I actually create a rectangle, and if it's a binomial, I label the top, so 8x and 2 and 3x and negative 1, and I create mini rectangles within that. Then I find the area of each rectangle. So 3x times 8x would give me 24x squared. 2 times 3x, because this 3x actually belongs to this length, and 2 is here. That's going to give me 6x. I'm going to do 8x times negative 1. That's going to give me negative 8x. And then I'm going to do negative 2 times 1, which is negative 2. Then I'm going to combine the like terms, which are these guys. And so my answer is going to be 24x squared minus 2x minus 2. Now these are 2 ways to do the exact same thing, multiply polynomials. Now the reason I like the area model is because when the polynomials get longer, such as this one, the area model works great because you can't FOIL this. You have to distribute, and distribute again. So watch how the area model can be neat and organized for us. So I tend to go the length across the top, so I'm going to do 3x, 3x squared, minus 5x plus 2. Now make sure you bring the sign with it, and then 2x and 1. I'm going to make rectangles inside the polynomial, and then I'm going to just find the area of each box. So 2x times 3x squared gives me 6x cubed minus 10x squared plus 4x plus 3x, I'm going to actually put the sign in front of it, minus 5x, and then plus 2. Now I'm going to combine all those like terms, and what you might be noticing is that the like terms, oh, this is 3x squared. I made a little mistake there, and you didn't catch me? Hopefully you did. The like terms are like diagonally from each other. Now that's not always true, but it's nice in this case. So we get 6x cubed minus 7x squared. Was that a negative? That was a negative 5x. So negative x and a positive 2. And there I've just multiplied the polynomials. All right, last thing I want to touch on is this. This is called the square of a binomial. And I know that most of you are going to look at this and you're just going to want to so badly distribute that 2 through and multiply. But you can't, because you have to remember that anything squared means those two anythings multiplied by themselves. So 2x minus 3 quantity squared is the square of a binomial. It means 2x minus 3 times 2x minus 3. So I would say that you have to be really, really careful on this. That's actually a common algebra mistake for kids to say that this is 4x minus 9. Now, if I multiply these polynomials, okay, in this case, I'm going to use the distributive property. So 4x squared minus 6x plus 9. You'll see that you still have a middle term. So just be really careful when you're doing these. Now, the really cool thing about when you square a binomial, your result is called a perfect square trinomial, which you are going to be learning about or reviewing in another video. All right, guys, have a great day.